So everyone, welcome to today's session on problem solving through programming in C. This will be the last session for this semester. So let's wait for a few more minutes so that others can join and then we'll start the session. So, hi everyone, let's start the session. So, this session will be recorded, so you can revisit the session after uh, the live sessions also, right? So, this is the last session. I will be covering the last topics that have been covered in the last week. At any instant, if you face any difficulty, such as my screen is not visible or I am not audible, please type in the chat box at that moment only. You won't be able to type, speak, right? So only I have the speaking privileges, right? So everyone please confirm once if my screen is visible. Anyone please confirm by typing in the chat box that my screen is visible. Great. So let me share my screen. Right. Right. So let's start. So let's start with one problem that I wanted to discuss today. Right. Ah, great. So what is the output for this function? Right. So right. So let's start. Right. So as usual, I have included my standard IO library here, right? Then and then I am declaring my function that returns an integer variable, right? The name is fun and it takes an integer n as input. Now the function is a recursive function here. You can see this is a recursive function, right? So here it can see this is the base case, right? Base case. And then this is the recursive case here. So this ensures that we have identified that our recursive function has a base case and a recursive case, thus it will exist. It will terminate properly, right? So it will give you some output. Now in the main function, now we go to the main function and we call this function fun of two. So whenever inside the printf, if you pass some formatted string, first the expression is being evaluated and then that is printed to the screen, right? So so first the function will be called fun with argument 2. So what is the output to this function, right? So let's start solving this problem. So what is the output of fun of 2, right? So you go inside the function loop. So let me draw a flow, right? So you have some input n here, right? Then you check n is equals to 4, right? If it's true, then what you do? You return n, right? If it's false, and if it is false, you return 2 into. So you call the function again. So the loop goes back. If it is false, it goes back with 2 into n, right? So this is how your program works. So let's see if this works, right? So for input of initial n is 2, right? Let's start solving this. So what will be fun of 2? So if you pass n equals to 2, right? So let me put values of n here. If n is 2, then this is false and it will go back here through this path. And now the input will be 2 into n, which is 4, right? So fun of 2 is equals to 2 into fun of, sorry. Okay, so you have to return 2 into fun of whatever is the output, right? Right. So 2 into whatever is the output of 2 plus 1, which is 3 here, right? So 2 into fun of 3 here, right? Now again, you need to evaluate this expression first to get the to set the values on the right hand side. So what is the value of fun of 3? Wait a second. So this is not going to work. Let me take it someplace else. Right. Right. So now the problem at hand that we had at our hand was function of n, right? It has two cases. So if n is 4, return n, else what you do? Else you call return 2 into function of n plus 1. And we want to solve for fun of 2, right? Fun of 2 is equals to, now since it's not 4, you have the value would be 2 into function of n plus 1, which is 3, right? Now let's start solving this problem. Now for in order to get the value of fun of 2, you need to first evaluate the value of fun of 3. So let's expand this function. So what is fun of 3? Now again, fun of 3, you see n is not equals to 4 here, so it does not meet the base miss criteria. So what you do? You again, so n is not equals to 4. So again, this value would be 2 into function value of 4, right? Now function value of 4 is essentially, this value is n, which is 4, right? So now this expression evaluates to 4. So this fun of 3 evaluates to 2 into 4, which is 8, right? So basically this fun of 3 is to 8 here, right? So finally fun of 2 would be, so this will give you function of 2 is equals to 2 into 8 is equals to 16, which is your answer, right? So let's see if we have reached the correct answer. So option C is the correct answer. Right. So the correct answer is option C, right? Anyone do you have any doubts in this problem? So this was a problem on recursion, and you are supposed to know how to understand how to actually evaluate recursive problems, right? Anyone do you have any doubts? So Ananya, what doubt do you have? You want me to go back? What is the doubt? Okay. Right. Right. So again, we were asked to compute the value of one of two, right? We are asked to compute the value of one of two. Now what we see, like 2 is, so the base case is if n equals to 4, then only return n. Otherwise, call the recursive case. So 2 doesn't is not equals to 4, right? So what you do, you go to the recursive case and you return 2 into function of n plus 1, which is 3, right? Now you cannot evaluate the value of this expression until you get the value of fun of 3. So what you do, the basically in the main memory, what you do, you push the stack pointer for this function call of fun of 2 here, right? And then you go to fun of 3. Now function of 3, you need to evaluate this value. Again, you follow the same logic. 3 is not does not evaluate to the base case, which is is not equals to 4. So you again return 2 into fun of n plus 1, which is 4 here, right? So fun of 4. Now fun of 4 is basically function of 4 is n is equals to 4. So what you return 4 here. So this expression essentially becomes 4. So you get fun of 3 is essentially 2 into 4, which is 8, right? So you get 8 here. Now you substitute this value here for fun of 3. So that returns 2 into 8 total, right? Now 2 into 8 is essentially 16, which is your fun of 2. Okay. These were the steps that you needed to follow. Right. So let's move on to the next problem, right? So the remaining topics that were covered in this session, in this week's session were, right. So the remaining topics were structs, right? What are structs? And then how to use them. Then pointers. What are pointers? We have already seen a little limited view of pointers, how pointers are useful. Then dynamic memory allocation, and then file IO, right? So I will solve one problem each for on these topics and solve any doubts if you have, right? So what are structs? So structs are useful in C programming language, right? So basically they are basically abstract data types. So they are data types that allows user to group several data types of the same of different data several variables of different data types, right? So they are very useful in organizing data, right? You can easily pass these kind of data in to functions using structs, right? So structs are very useful way. So essentially, how do we get to structs? What is the intuition on structs? Why do you want to use uh, structs here, right? So let's see a use case, right? Now let's say this is your problem statement here. So let's see two problems and then we will get to know how structs are useful. So you have a list of marks of all students in a class, right? And you want to pass that list for processing. Pass the list, pass the list for processing to a function in C, right? So how to do this? It's very easy, right? It's very easy to do this, right? What you do, you create a array, right? Let's create an array here of let's say float data type, right? And each index of the array represents the roll number of each student in the class, right? So let's say your register looks like this. Let me create a register first. So let's say the class register looks like this. So you have your roll number here, roll number. You have your name entry here. Then you have your marks here, right? And then let's say you want to add more details. For example, which house does the student belongs to in that particular class, right? So let's say this is your register for the class containing the student details, right? Now your roll numbers start from 1, 2, 3, 4, and so on. So these are your students. Your student name can be Ramesh, Suresh, Ram, Sita, something like this. And the marks can be stored in the marks table. Let's say Ramesh scored 90 out of 100, Suresh scored 95, Ram scored 80, and Sita scored 75, right? Now, let's say Ramesh is in red house, Suresh is in yellow house, right? Ram is in green house, Sita is again in red house, right? So let's say this is your table database for your class, and now you want to digitize this data in your C program, and then you want to use that data for some sort of processing. So let's say I want to process the marks table here, right? I want to process the marks table here, and I want to do some sort of, I want to analyze what are the marks for the students. So what I can do is I create an array of floats with indexes as roll numbers. So this is roll number one. Okay, yeah. So index plus one as a roll number. So this is roll number. So float. Let me float array here. So this is a float array here, and then these are your index, and then from index you can compute the roll number, right? So 0, 1, 2, 3, 4, 5, and so on, right? And the roll number will be index plus one, right? And so on, right? So now I can simply map this column, this marks column here, onto this float array. So now roll number one is for Ramesh, who scored 90. Roll number two is for Suresh, who scored 95. Similarly, roll number three and roll number four, and so on, right? In this way, you can create your array in C, and this is very useful. Like you can use arrays for this kind of operation. Now, let's say I want to create a program so now if you are using this kind of approach, whenever you are using arrays, there is a limitation. So let's say if my functions expects the names as well as marks of the students, then there is no way to use, you cannot use standard C arrays to store that kind of data in a single variable and pass it to a function, right? For processing. So you cannot create arrays always allow you to create data types of variable store values of the same data type, right? Multiple contiguous values of same data type. So you cannot have an array that stores string, comma, float, right? You cannot. This is not allowed, not allowed in C. So what to do? What you can do? Then then structs come into picture, right? So this is how structs are useful, right? So this is completely not allowed, right? So what you do, you use structs, right? So this is the beginning of structs. So what are structs here? Structs allow you to store, allows us to store variables of different data type in a single variable, right? So now what is the syntax for struct? Again, nothing, it's very simple. So the keyword struct is used to struct, then struct name, and then you use this curly braces to define the body of the struct. Now let's say I am declaring an int arr of size 10 for the roll numbers, and then I'm using float arr of size 10 marks, sorry, yeah. So let me use correct names here. Then in the struct, I can declare my variables as int roll number. So it's a roll number array that contains 10 elements. Then I can declare float struct array here, float marks that contains 10 elements here. And then you can use a array of characters that stores the first character of the first name. So char names of 10 elements here, right? So now your struct is complete. So you can use this struct to store all these columns. So you are able to store column roll for roll number, column for name, as well as column for marks in the same variable, right? So this is why structs are used, and that's why these are useful, right? So this is very basics on structs. Hmm. So right. So now let's start solving the problems on this. Right. So what is passed if you pass a structure variable to a function, right? So copy of the structure variable, reference of the structure variable, starting address of the structure variable, or ending address of the structure variable. So the correct answer is option A, copy of the structure variable. So structs are passed by value in C. Option A, copy of the structure variable. What does this mean? So let's see what does this mean. So let's say I have this struct variable that stores integer value int x, right? Right. So let's say I declare my struct variable that stores integer and a character variable. Let's char y, right? Now this is my structure variable. Now what I do, I declare it, create a variable, create a struct, right? So you use the syntax to create a struct, which is struct keyword, then followed by struct type, and then let's call it data, right? So now you have successfully created your data. Now you can initialize it, right? So you can say data dot x is equals to 10 and data dot y is equals to a, right? So now you have initialized your struct data. Now this data structure struct contains these values. Now let's say I have your function here. So let's call my function update. Let's call it update here, and it takes a data type of struct var value, right? And inside the function, what you do, so this is a void function, and inside the function, what you do, you set y dot val. So val dot x is equals to 1. So I'm resetting the value of x, and then val dot y is equals to c, right? I'm resetting the value of y also. Now when in my main function, if I call this update function, update, and I pass my data struct here, right? And then I try to printf, and let's try to print the x value, percentage d, comma, percentage c here, right? And I print data dot x, comma, data dot y. You will see that this will print 10 and this will print a, right? But whereas in the update step here, I was changing the values of x and y stored in that struct variable, right? So this is what happens when you have pass by value used in your function, right? So a copy of struct is being made here. So now this val is a new copy of the struct. A new struct is created in the main memory. So again, let's see. So this is your main memory, right? Main memory. So let's say at this line, so at this line, struct of data is stored here. Now you call your function and do whatnot. And then when you call this function here in this line, another copy will be created for the val struct, right? This is a new struct. Now all changes are done to this struct and it will get destroyed as soon as the function exits. But this remains in the memory, and when you reuse it, you get the correct value, right? Anyone, do you have any doubts for this problem, in this problem? Anyone, if you have any doubts, please type in the chat box. Great. So let's move on to the next question. What function is used to write a string to a file, right? So f puts, f printf, f write. Anyone? I think this was covered in the session itself. Right. So the correct answer is all of the above. Fine. So f puts allows you to write a string to a file, right? So yeah. It only allows you to write raw strings onto the file. Then you use fprintf. Fprintf is useful for uh, let me write it here. So write strings to a file pointer, right? Then when you talk about fprintf, what it does, writes formatted strings to the file pointer. So we'll see the difference between these two. And then fwrite again. So fwrite is useful for writing binary data, but can be used to can be used to write strings to file pointer, right? So the correct answer is all of the above. Option D, right? So now there is one question, how to use these functions, right? So let me give you one example each for this function, right? So I will just show you how to use these functions in your C program. Let me open up the right. Hmm. And save file io.c. Okay, right. So let me share my screen here. So I hope my screen is visible, everyone. Right. So now again in my C program, I'm including my standard IO library and then the string.h. Then you have to open a file pointer. So there is a keyword file, right? So this file keyword allows you to create a file pointer, right? And then you use the function fopen to open the file pointer to a given file. So let's say my file is log.txt. And then to fopen function, you need to pass the file name as well as the mode, in which mode you want to write the text, right? Write the string. So there are three modes: read, write, append, then a combination of these three, right? So let's open it up in write mode. Now let's check. So this FPTR is a pointer, right? It stores a pointer to the open file, right? So if this is null, then we were failed to. So if this is null, then I can give the user a error message, printf error failed to open file, right? So yeah, right. Otherwise, we can use fputs. So using fputs, you can say only print, only store raw strings to file pointer here, right? And then finally close my file. This is very important, closing your file. Otherwise, your program will keep it open and you will get separate different kind of errors, right? So let's go ahead and compile our code, right? So I will using GCC here, GCC file io.c. So you can see in my directory right now, right? So let me just create a new file, right? mkdir file io, mv file io.c to file io. So in my current file, I have only one file, file io.c, and then I should compile is this. So I have two files here, file io.c and a.out. And now in my program, what I'm doing, I'm opening a file pointer to the file name log.txt. I'm opening it in the write mode and I'm writing some text string to that file, right? So let's see if our program succeeds in doing this. .a.out. Now, when you look at the contents of your folder, you can see here, right? Everyone, please pay attention. A new file has been created with the name log.txt, and let's open it up. Okay, so I think window file value. So now let's see. Right? Right. So now you can see in my folder, I have a new file named log.txt. So let's open it up here. So log, you can see it has it stores this file. The contents of the file are user logged in at 10 a.m. Right? I can change the string here, and I can say my name is Rupesh Kumar. Right? And again, I can run compile my program and run a.out, and then you can see the file has been updated with the name, my content, my name is Rupesh Kumar, right? So this is how you can use fputs, right? I can always open up in append mode here, from where I can append text to my file. So this is a new line, So now when I compile my program and run the program, you can see it appended a new line in the existing text file, right? So you can use it in append mode also. Or yeah, yeah, these are right. This is the use case of f puts, right? So this is f puts here. Now let's see how to use how to write formatted strings to text files. So for this, we will see an example using f printf, right? F printf used to write formatted strings. Now, what is the difference between normal string versus formatted strings? Normal strings versus formatted strings, right? What is the difference? So in normal strings, it's purely string. So let's say I am declaring a string like this. So my string was, this is a new line. That's it, right? So this is a normal string. Now, if my string requires some sort of evaluation, right? For example, while using printf, what you are doing, whenever we write printf statements, what we do, printf, and then we write something, right? And then use format specifier to print something, right? So now whenever these kind of strings are encountered in C, they are called formatted strings, which require some evaluation before putting it on to the stream buffer, wherever you are trying to put it on the terminal, so standard IO, or maybe on the file, right? So these kind of strings are known as formatted strings, right? Now, this is useful in cases where the programmer does not know the exact string that has to be printed during the compile time, right? During compilation, you don't know. During the compile time, you don't know. So again, let's see how to use fprintf here. So now again, I open up my file pointer, a file using the file command here, file, and then asterisk fptr, which is essentially a way to declare pointers, right? Then fopen, my file name is results.csv. Let's say I'm trying to, let me create it results.txt here. And then I open up in write mode. Now again, I do check here if my file was successfully opened or not. So let me replace this statement here. Right. So right. So I can simply tell the user if the program was able to uh, print, right. So now here, what I'm doing, I'm creating a character as a pointer item, right? And for now, just assume that character pointers are essentially strings, right? Right. So char asterisk item essentially represents a array of characters, which is a string. So I'm storing the string widget here into this variable item, right? Then my quantity is a variable that stores 25 and float price is 19.99. Right. Now I want to write a CSV file. So I hope every one of you have seen spreadsheets, right? So for example, my in the example that I was doing where I was writing the details for the student details. So let me transform this problem into that kind of problem, right? So what was being stored here, right? So what I can do is I can simply create a struct here. So let me create a struct here. So it will combine both problems. Struct class register, right? So inside the struct, I have my variables int roll numbers, right? And 4 students. Then I have my array float marks for 4 students, right? And then yeah, right. So let's say this is my class register. I want to store this kind of data, right? So in my program, what I do, I declare the register class here, register object here. So register, right? And then I will set the values to the, oh, sorry, reg, right? Right. Now what I will do, so here you can see when I created the variable with name register, it's highlighted in blue. This is why, because register is a predefined keyword in C. So you cannot use predefined keywords in C for variable names, right? So I created a new variable regular, right? So now I need to assign the values to its variables. So right. So I can just iterate for int I equals to 0, I is less than total number of students are 4, I plus plus, and inside the regs roll number at I can set the roll number as I+1. We already saw that this was the mapping that we are using. And then for the marks at I is equals to, let's put it 90 plus I, right? So now I have filled my struct here. Right? So now my register is complete. Now what I want to do, I want to write the contents of this register in my file, right? Right. Let's also add the name here, right? Correct student names here. Right. So let me create a character array, char names. Right now, the names will be character arrays of two different types of data types, two-dimensional array, right? So first, the number of entries in the character array, the number of rows will be the number of students, right? And so we have 4 students here, and the maximum number of digits in the names of the students. So let's say 10 here, right? Right. So now I have added my register is complete. I have names. I can also use house details here. Again, it is 4 and house is 5 maximum string, right? So this is how you create arrays for strings in C, right? So let's fill in the details for names here, right? Reg.names at 0 was Ram. Wait a second. So let me just assign the values here. Right. So essentially, you cannot simply assign strings directly, right? So you have to use string strcopy. Yeah, right. Because the memory has already been allocated, right? So what you do, you simply compare it using CPI, and the syntax is the output location. So reg.names at 0, comma. The first student was Ramesh, right? Similarly, fill all the details remaining. Suresh, then Ram, and then Sita, right? So this was student at 4, student at 3, with index 3, roll index 2, roll number 3, again index 1, roll number 2, right? So these are the names, and then I will enter the details for what the house, right? House at 0. So Ramesh was in what, red house, let's say. Then Suresh was in greenhouse. Then Ram was in yellow house. And then Sita was in red house again, right? Right. So now I have created my struct successfully. So it contains all the details, so roll numbers, marks, names, and house, right? So yeah, so there are few things. So you cannot directly assign a new struct array to the existing struct array, string arrays here. Why? Because it already has created some memory location in the memory that cannot be overwritten, right? You have to copy contents to that memory location, right? So now you have this struct data here. Now what I want to do, I want to write this data to a spreadsheet, right? Spreadsheet, right? So I hope you all have seen spreadsheets. So you know how the entries are stored. So the column names would be column names are the column's name would be name. So let's say roll number, then name, right? And then your marks, and then house. Let's see how we can simply print the details here, right? How can we write these details into the string? So your actual struct would look like this. So roll number 1, name is Ramesh, marks are 90, and house is red house. Similarly, your second entry will be 2, name will be Suresh, marks will be 91, and house will be green. Then roll number 3, name will be Ram, marks will be 92, and house will be yellow. And then rule number 4, the name will be Sita, marks will be 93, and house will be red, right? So your table should look like this. So let's see if I'm able to write these contents onto a string file. So let's open up my file in append mode, right? So let me take my file pointer here. So what I do, I open up my file in append mode, right? So let me open it in the, yeah, write mode also works, right? I'm simply writing the contents. So I can simply use the f statement here, f print, which allows you to print formatted strings, right? So the file pointer is fptr, and then let's first enter the column names here, right? So first row of the file should be uh, these column names, right? Right. Right. So this will write your first column of the entry. Now what you can do, you can loop through the rows in the struct less than 4, I plus plus, and simply use fprintf again to write the each row of the file. Right? So this will be percentage d because it's an integer. Name is percentage s, right? And then marks are percentage f since it's a float. House is again percentage string, right? And then you can pass the format values. So it will be register dot roll at I, comma register dot name at I, right? Again register dot marks at index I. Finally register dot house at index I, right? So now what you are able to do, you are able to use. Now, what we did here is first we printed the first row, which is the header of our spreadsheet that contains the column names, roll number, name, marks, and house. And then we change the line. And then for each entry in our database stored in the struct register, I print the formatted string like this. So the formatted string prints an integer followed by string, then marks, floating values, and then finally string, right? So now the values stored are registered or roll at index I. So I'm iterating from 0 to 4. Then register dot names at I, then register dot marks at I, and then finally registers at house at I. So first this string will be formatted. First this string will be evaluated. Then only it will be written onto the text file, right? So now what I can do, I can simply compile my program. This is the file io.txt. Let me key marks. So let me call the name of file is as register.txt. So let's compile my file and then run this file. And then you can see in my file directory, there is a new file named register.txt here, and that contains these entries with, okay, let me rename to CSV. Right. Right. So now you can see your CSV file here, right? So yeah, let's use CSV here. So CSV stands for comma separated values, right? So here you can see the column contains strings separated by comma. Again, the rows of my tables contains values separated by commas here, right? So comma separated values are essentially yes, CSVs. So now I'm writing my content to my file register.csv, right? Now you can see in the register.csv, I can simply preview it, right? And you can see it contains the roll number column here. So for roll number one, name is Ramesh, marks are 90 and house is red. Similarly, roll number two, and then yeah, and so on. Right, everyone? Is this clear? Do you have any doubts? Anyone, do you have any doubts in this? Y- Yeah, someone is asking why it is register at I dot name. Let me copy the query here. So the question is why I'm using this kind of approach where I'm saying use the struct variable register and fetch its variable name inside it. And then name is an array. And from that array, I'm getting the values, right? So someone is asking why it shouldn't be, why not register at I dot name. Now this is wrong. Why? Because this says I'm creating an array of structs here, right? So in reality, I don't have an array of struct here. I have a struct that contains arrays, right? So you have a struct, then you point to its particular one of the arrays, and then you fetch the value for that array. That's why it's struct dot value variable at index, right? So it's not an array of structs, it's struct containing arrays. Is this clear? Is this clear? Can we proceed to the next problem? Great. So this is how you can use structs as well as formatted strings here, right? So this is the use case of formatted string. So you don't need to write these strings again and again. You can simply pick up a registered stored database and use formatted string to loop through the values and write onto the file, right? And the last thing here we will be seeing is, wait, right. So the last thing we'll be seeing is how to use fwrite to write text to a file, right? So again, now you open your file pointer using fopen here. The file name is buffer.txt and you open it in write binary mode because fwrite is used for writing binary text, right? Binary contents. Now I have a message stored in a string message here, right? And this says this is a fixed size buffer message, right? And then I will be using the fwrite command. The first argument is the binary buffer that needs to be written. So it is the string message here. Then it asks for the size number of bits in the message. So you can use size of variable here, function here, size of, and you pass in the character. So it takes character size, right? So what is the length of each element in the character? So it So since it's an array of characters, the length of each array is size of char here. Then you pass how many elements are going to be written. So use strlen of message. So strlen, what does strlen does? It returns the total number of characters in present in a string, right? And then finally the pointer onto which you want to write this file pointer to which the buffer where you want to write the text, right? So this is how you use fwrite function here. So again, I can compile my file and then run my file. And in my file directory, you will see there is a buffer.txt created here. And this file contains the content. This is a fixed size buffer message, right? So this is how you use fwrite, right? So we saw that how we can use three different kinds of approaches for writing text to strings to files, right? Anyone do you have any doubts? Please type in the chat box. Anyone do you have any doubts? Great. So let's move on to the next problem. Right. So this is the next problem. Can a structure contain a variable of its own type? Anyone? This has been covered in the class lectures only. No, a structure cannot contain a variable of its own type, right? So a structure cannot contain a variable of its own type in C, right? Right. So yeah. Does anyone know any reasoning behind this? You want to share any reasoning? So like the question says, can you declare something like this? Struct data, right? And inside the struct body, what you define? Let's say I have an int role, right? And then I'm saying, can I create something like this? Struct data, new data. Is this valid declaration for a struct in C? So the correct answer is it's not valid. And the reason behind this is essentially when you are creating a new variable here, new data here, you need to assign some memory to this variable, right? So whenever in C you are declaring any variable, a fixed portion of memory is assigned in the main memory where the values held in the variable will be stored, right? But what happens is when you are so for that you need to know the size of that variable beforehand, right? But here the size of struct data is not known, right? It is not completely defined here. Thus, this is not allowed, right? So this is not allowed, right? Yeah, so it's not allowed, right? This is the reasoning behind this. Now there is another question. Anyone do you have any doubts in this logic or anything related to structs? Please type in the chat box. Right. So let's move on to the next question. So can a struct contain a pointer to its own type, right? So we already know what are pointers. Pointers are variables that store memory locations, memory addresses for other variables, right? So for example, if I want to create a pointer for an integer variable, so what you would do, you will use the syntax int followed by asterisk and then the pointer, any variable name, right? So now this variable ptr now can contain the pointers, basically the pointer that that points to the memory location in the main memory where the variable will be stored. So I can just assign it something like ampersand x, right? So ampersand gives you the address of the variable x. So for this, you need to ensure that you have declared a variable x here, right? So now PTR contains the pointer to the memory location where X has been stored, right? So now the question is, can a struct contain a pointer to its own type? So what does this mean? So can I use something like this? Struct data asterisk new data, right? Asterisk new data. So is this allowed? Anyone? Right, this is perfectly allowed. Why? Because it's a pointer data type. It doesn't require to know what the actual memory size is. It just needs to know at what beginning location, memory location, the variable will be stored. This is so thus this is perfectly allowed, right? Yes, this is. So you can use this kind of approach for declaring structs inside structs if you want to refer to structs, right? And it is very useful for creating linked lists in C, which are very powerful data structures, right? Maybe you will see these data structures in your future semesters, right? So right now, just know that there is a way to use this kind of behavior, right? And there is a use case for structs, a very huge use case, I would say, very important use case. Yeah. Anyone do you have any doubts in this? Please type in the chat box. Anyone do you have any doubts? Right. So let's move on to the next question. Find the output of the following program. Right. So you have a character array A here. So it's a string, right, or character array that contains the characters, like an array of characters. And then I'm declaring a pointer char asterisk p that points to the starting memory address of the array A here, right? And I'm saying plus plus p. And while p is asterisk p is not equals to e, printf asterisk percentage c asterisk p plus plus. So before solving this problem, I want to ask you guys one question. Do you know anything about pointer arithmetic? What does pointer plus one, pointer minus one means? Right. So before understanding this or solving this problem, we will have a brief overview of pointer arithmetic, right? Mm. Right. So we all know what are pointers. So let's, for understanding pointers and pointer arithmetic, first let's create a memory layout for the main memory. Right? So this is your main memory. And let's say I am declaring an array of integer data type, right? That contains these values, right? Now, what happens when you declare this array in your memory? Some memory blocks are stored here. The contiguous memory blocks are allocated for this variable x, and the values are stored in the subsequent memory locations. And let's say the memory locations are like this, and let's say integer takes 4 bytes in your main memory. So this new location would be 1004. The next location will be 1008, and the next location will be 1012. Right. So these are the starting point memory location of the starting of each of these blocks. Right. Now, let's say I'm creating saying that I have a character pointer, an integer array pointer, integer pointer, int asterisk ptr is equals to a x. So what does this mean? This means this our pointer here points to the starting of the beginning of the array memory location. So now ptr points to this memory location, which starts at thousandth bit in my byte in my memory, main memory, right? So now this stores 1000 here, right? So now when I say ptr plus plus, what does this mean? It doesn't mean 1001, right? So this means 1000 is stored here. It doesn't mean not equals to 1001. Essentially, it becomes equals to 1000 plus 4. Why? Because we are doing pointer arithmetic. So whenever you do arithmetic using pointers, you need to take care of the size of the data type that you are pointing to using the pointer. right? So, and since integer is taking 4 bytes here, so now PTR plus plus will point to the memory location at 1004. So now PTR plus plus will ensure that now my PTR is here, right? So initially my PTR was here. So now this increment. So when you increment it, so you get PTR that in points to the starting memory location, which is 1004, right? So this is how pointer arithmetic works. So you can use multiple operations such as PTR minus minus. You can do PTR plus equals to 5, right? You can say PTR minus 5, right? You can always do difference between two pointers. So PTR1 minus PTR2, which essentially returns the number of elements. Elements. That's it, right? These are some refresher on the pointer arithmetic. Now let's go ahead and use this program, right? So our program looks like this. So inside the main function, I have these lines. So character here, char a, a, b, c, d, e, f, g, h, right? So now you have your character array here. Then I'm creating a pointer char asterisk p is equals to a. So it points to the starting memory location. Now what I'm saying, I'm doing plus plus p, right? And then, so this, what does this increments my pointer p by one length, one size in the array, right? So it jumps to here now. Now my p points to here, right? Now what I'm saying, I'm doing while, and I'm using the dereference operator here. Note that whenever you use asterisk with a pointer variable name, then you are essentially dereferencing the variable and you are fetching the value stored at that memory location. So when you dereference the value p, pointer p, and you check if this value is not equals to e, what you have to do? You have to printf, sorry, yeah, you have to printf percentage c. So you are printing characters here, right? Comma, asterisk p plus plus, right? And then finally you program exits, right? So we have to see what will be the output of this evaluation, right? So let's do this. Let's see how the data is stored in our main memory, right? So A, B, C, D, E, F, G, H, and so on, right? So my data is like this. A is stored here, B is stored here, C is stored here, D is stored here, E is stored here, F is stored here, G is stored here, and then H is stored here, right? So this in the main memory, my data is stored like this. So at this line, I'm saying char asterisk p points to A, that is beginning location, beginning of the pointer. So now p points to this memory location, right? Now in this line, what I do, I increment by 1 unit of the size of the character array. So this jumps from here to this, right? So now p points to this beginning location here, right? Now my while check is while dereference the pointer. So what is the value stored at the memory location at which p is pointing, and take that value. So the value is b here, right? B, and you compare it with E. So B is not equals to E. So you can directly do character comparisons, right? So it essentially compares the ASCII values. Now B is not equals to E. That's true. So what you do, you go to this line and you print the character at, now again, here you are saying asterisk P plus plus. So this is post fix, right? Post fix increment. So first use the value, then increment the pointer. So what is the value stored at asterisk p? So the value stored at asterisk p is what, b, right? So you on the screen. So let me just draw my terminal output here. So let's say this is my terminal, right? So it prints B here, right? So asterisk P was B here, right? Now, once you have done this, again, you jump back to the control to the beginning of the loop here, right? So again, so after this, you increment the character pointer by 1 unit. Again, this jumps from here to here. So P comes here now. Now again, asterisk P is C. So C is not equals to E. Again, you print the value C again here. So C is printed here. C is printed here. And now my pointer jump takes place here. So it jumps from this to this memory location, right? Now P becomes this. Again, when you dereference, you see D, which is not equals to E, right? So what you do, you print the character by dereferencing. So you print D here, right? And then you use the postfix increment to point to this location, D. Now, when my pointer points to this starting memory location, and then when you dereference it, it becomes E here, and E is equals to E, right? So this statement becomes false here, and your while loop terminates, right? Terminates, and then you simply return 0 here, right? So your while loop terminates, and the terminal output is BCD, right? This is what you will see on your terminal output. So the correct answer would be option B. Anyone, do you have any doubts? Anyone, do you have any doubts? Please type in the chat box. Fine. So let's move on to the last problem for this session, right? So let me write down the problem here itself. It's a problem on array of structs, right? So first I'm declaring my structure here, struct here. So struct, the name of struct is point, right? And the values, its variables it holds are int x and int y, right? And then this is my struct. And then in my program, what I'm doing, I'm creating a struct point, and I'm creating an array here with two entries, size two, right? So what this line is saying, I'm creating a struct point, array of struct point, right? Which contains two structs in the array. You can create an array of structs, right? So now let's create my two structs, right? Point P1 is equals to 13 comma 14, right? And let's create another struct here, struct point P2 is equals to -1 comma -5, right? So now you have these two structs. And finally, let's assign the struct. So in the array of structs, the 0th index contains pointer. So it's an array of struct that contains the pointers to the structs, right? It contains the pointers to the struct. Since it's you are creating as using asterisk here, you are creating an array of pointers of struct data type. right? So we all remember, like, if you want to create an pointer, what you do, int, use the data type name and followed by struct, this asterisk here, and then the pointer, right? PTR is equals to ampersand x. This is how you use to create. So the same structure, syntax you can use for structs also, right? So now ARR at 0 will contain the address to the struct P1. So ampersand P1. Again, ARR at 1 will contains the address to struct P2. Now in my main program, what I am saying print f the value, which is an integer here, ARR at 0 dot y, right? So everyone, I hope you are familiar with this right arrow here. So right arrow is used whenever you are trying to point to the values stored by a struct using the pointer to that struct, right? So it says what is the pointer pointing to which struct at index 0 in the array ARR, and then fetch the value of y from that struct, right? So I hope you all can answer now. What is the answer here? So ARR at 0 points to P1. So you again go to P1 here. And what is the value of Y for P1? The value of Y is 14. So the correct answer would be 14 here, right? Right. Great. So anyone, if you have any doubts, please type in the chat box, right? So this was the last problem that I had for you guys for this session. If you have any queries, any doubts for this for this course, for the tutorial sessions that I have taken, you can ask me, right? The sessions are officially over. If you have any doubts, please type in the chat box. So fine. So someone had doubts in integration methods, right? Rangaputta and trapezoidal rule, right? So as I covered in the previous session also, let's say you have some function for which you don't know the integral equation and you want to find the area of under that function, under that curve. For example, here I am taking y equals to x squared here. So, so one way is you integrate the function and use the method that you have been taught in your intermediate classes, and you can get the solution, right? But there are functions where you want to get the area, but you don't know how to get the area, but you can evaluate the function itself. You don't know the integral. Then in that case, you can use some numerical approximations, and one of them is the trapezoidal rule. What it says, you take the points, samples within the function, right, under the function at different locations, right? So, for example, you want to compute the area under this curve. So what you can do, you can define a trapezoid that fits this function best, right? So this was your original function. Let me redraw it. So the original function looked like this, right? So now what you did, you fit a trapezoid, considering that these two lines as the parallel lines and then joining the ends to form a trapezium here. And then you know the formula for computing area of a trapezium, right? Then you can simply get the area of this trapezium and you'd say this is the approximate area under this curve, right? Now what you can do, you can see the error here is very large. So this area is wrongly approximated, and you want to reduce this error. Then what you can do, you can divide the curve and sections into multiple trapeziums, small trapeziums. So I took 3 segments on my x-axis here, took the function values at the ends and divided it into 2 trapeziums here. Now, when you increase number of as you increase the number of trapezium, you can see the error reduces very highly. So here the error was all this area here, all this chord area here, right? So now here the error has reduced by a lot, right? So this error is very small as compared to this. So now you can not only you can fit a single trapezium, you can fit multiple trapeziums within the for computing the area under the curve, and then you can get better and better approximations, right? So this is how you can use trapezoidal rule to compute the area under curve. Is this clear? So this is the overall idea, and if you want to see the actual details and the algorithm that I devised here, you can go back to the previous sessions recording and see it, right? Now Rangakutna method is a way to solve ordinary differential equations, right? So there are iterative methods that are useful for basically integrating differential equations, right? So they are useful for solving problems of this type, right? So let's go to Rangi methods. Right? So let's say you have a problem of type like this: dy by dt is equals to f of t comma y, where y of t0 is equals to y0. So initial value problem. You know the ordinary differential equation here on the left hand side, right? And you know the initial conditions, and you want to find y as a function of t, right? What should be the y value of y as a function of t? One of the easiest ways simply just use the if it's possible, if f of t comma y can be written as a function of g of t plus h of y, right? Some combination of these, some combination. And if you are able to factorize h of y out from here, so g of t into h of y, some function of g of t into h of y. If this is the case, then you can simply integrate, bring h of y here, keep g of t there, and integrate this, right? Use indefinite integration and then use the conditions at the initial point to get the actual function of for y, right? If this is the case and the function h of y and g of t are essentially integrable, then only you can use this approach to solve this problem. But if not, what you can do, you can again use numerical approximations. So this is the problem statement that we are trying to solve. So Ranga-Kutta method are useful for these kind of approximations. So before moving on to Ranga-Kutta, you should know the easiest known method to solve this problem is. What is the easiest way to solve this issue, right? So you all know that the first order, first principle of calculus, that limit delta t tends to 0, y at t plus delta t minus y at t by delta t, this quantity tends to dy by dt, right? So let's choose some finite. So for finite delta t, we can always say y at t plus delta t minus y at t is equals to delta t into dy by dt, right? So if dy by dt is known, delta t is some finite, then you can always get the value of y at t plus delta t is equals to y at t plus delta t into dy by dt, right? So this is one of the ways to solve this problem, right? So for this, you need to know how to evaluate dy by dt for given y, right? So this is essentially this belongs to the one of the methods for Euler methods, right? Euler method. And when you in your future semesters, if you take up some postgraduate graduate course on numerical algorithms, you will see that this method is very erroneous and the errors are very large. So to get better approximations, a method has been devised, which is the Ranga-Kutta method, right? Which says y at t plus delta t can be computed as y at t plus delta t by 6 into k1 plus 2k2 plus 2k3 plus k4, right? Where k1 is the function value at uh, t comma y at t, right? K2 is function value at t plus delta t by 2 comma y at t plus k1 delta t by 2, right? So you know how to evaluate function already, that then only you can do this. K3 is f of t plus delta t by 2 comma y of t y at t plus k2 into h by 2, and k4 is essentially f of t plus delta t comma y at t plus delta t into k3, right? So when you substitute these k values into this, you can get a value of y at t plus t. Here you can see this is similar to this formulation, like this is solving the same problem as the above formulation, but in a different way, which is more numerically accurate, that you don't know right now. You haven't learned that concept here, but yeah, Ranga-Kutta method is a better way of solving these kind of problems, initial value problems with much accuracy. So yeah, this is the Ranga-Kutta method, right? So anyone, do you have any doubts, remaining doubts? If not, we can end the session. Great. So anyone, do you have any doubts? If you have any doubts, please type in the chat box, or we can end the session. Yeah, someone is asking, is this related to C programming? So actually, there was a session. So essentially, this is these kind of algorithms are coded using some programming languages, and you can hard code Rangakutta method and Euler methods for solving problems this is very much useful in simulations. So physics based simulations where you need to solve these kind of differential equations. A basic example would be a projectile motion where you want to find the location of the projectile at a given time step, right? So yeah, you can write a C program for these approaches. So it seems no one has any doubts. So let's end the session. Thank you all.